Hello everyone, welcome back to another video. So in this video we're going to discuss about what is Kubernetes and why we use Kubernetes. So let's get started. So for the very first step you have to know about that what is Docker. So basically, a Docker is a containerization platform used to make it easier to create, deploy, and run applications using containers. So, what is containers? So, container is a type of virtualization technology used to package and run application in isolated environments. Containers provide a way of application to be isolated from the underlying infrastructure and each other, allowing them to run securely and independently. Container also allows application to be quickly and easily moved from one environment to another. So, by using containers, developers are able to package an application with all the parts it needed, such as libraries and other dependencies, and allows it as one package. So, this make it easy to manage and deploy application as the container contain everything needed to run the application. So, let's move on to the next. What is Kubernetes? So, Kubernetes is also known as Kubernetes or Kube. So, it is a container orchestration platform for scheduling and automating the deployment, management, and scaling of containerized application. So, basically, Kubernetes was firstly developed by engineer at Google before being an open source in 2014. So, basically, Kubernetes is an open source platform. Uh, First, you need to create a Kubernetes cluster. You can do this with the help of cloud providers such as uh, Google Cloud, AWS, and Microsoft Azure. So, once the cluster is up and running, you can deploy application with it using containers such as Docker. So, in the next step, Kuber helps you to manage the resource in your cluster such as CPU and memory to ensure that your applications are running as efficiently as possible. So, Kubernetes can automate the deployment process, ensuring that your application is always running and up to date. So, Kubernetes provide a range of monitoring tools to help you keep track of performance and health of your application. So, as your application grows and demand increases, Kubernetes can helps you to scale up the resources to meet the demand. So Kubernetes can also automate the process of rolling. So today Kubernetes and broader container ecosystem are maturing into a general purpose computing platform and ecosystem that rival, if not surpasses, virtual machine, that is VMS, as the basic building block of modern cloud infrastructure and application. This ecosystem enable organization to deliver high productivity platform as a service that address multiple infrastructure related and operation related tasks and issues around cloud native development so that the development team can easily focus solely on coding and innovations. So what does Kubernetes do? Basically, Kubernetes schedules and automate container related tasks throughout the application life cycle, including deployment, rollout, service discovery, storage provisioning, load balancing, auto scaling, and self healing for high availability. So, deploy a specific number of container to a specific host and keep them running in a desired state. Rollouts. A rollout is a change to a development. Kubernetes lets you initiate, pause, resume, or rollback rollout. So Kubernetes can automatically expose a container to the internet over a to other container using DNS name and IP addresses. Set Kubernetes to mount persistent local or cloud storage for your container as needed. So Kubernetes load balancing can distribute the workload across the network to maintain performance and stability. When traffic spikes, Kubernetes auto-scaling can spin up new cluster as needed to handle the workload. So when a container fails, Kubernetes can reset or replace it automatically to prevent downtime. It can take down container that don't meet your health check requirement. So move on to the next, that is why we use Kubernetes. So, the first step using Kubernetes is to set up a cluster. So, a cluster is a set of computer, you can say nodes that are connected and running Kubernetes. So, this cluster can be on premises or on the cloud. Once the cluster is set up, you can deploy application to it. This is done using Kubernetes objects such as pod, services, and deployment. Kubernetes can make it easy to scale application. You can easily add or remove nodes to a cluster to scale up and down as needed. So Kubernetes provides built-in monitoring capabilities that allows you to keep an eye on the health of your application. So Kubernetes also allows you to manage the resource your application use, such as CPU and memory, to ensure that they are used efficiently. Kubernetes make it easy to automate deployments, allow you to deploy your applications quickly and reliability. So that's all for the Kubernetes. Let's move on to the pods and the nodes. So what is Kubernetes pods? So when you created a deployment in module 2, Kubernetes created a pod to host your application instance. A pod is Kubernetes abstraction that represent a group of one or more application containers such as Docker and some shared resources for those container. Those resources included shared resource as volumes, networking as a unique cluster IP address, and information about how to run each container, such as container image version or specific pod to use. So basically, pod is in Kubernetes are the fundamental unit of deployment. So a pod model application specify specific logical host and can contain different application container which are relatively tightly coupled. For example, a pod might include both a container with Node.js app as well as different container which need to be published uh, by the Node.js web server. The container in a pod share an IP address and pod speed are always correlated and co-scheduled and run in a shared context in the same node. So basically, a pod in the smallest unit of deployment in Kubernetes and is the primary unit used to organize and manage application. A single pod can contain multiple containers such as web servers, a database, a caching layer. So you can see pod are the atomic unit on the Kubernetes platform. When you create a deployment on Kubernetes, that deployment create pods with containers. So you can see that there are four ports like port 1, port 2, port 3, port 4 in the so there are individually like IP address of each port you can see on the screen. So in the port 1 you can see that there is only one container. So and in the port 2 there are two containers, and the port 3 there are three containers. So they are a group of one or more containers. So each pod is tied to the node which is scheduled and remain until termination according to restart policy on deletion. In case of node failure, identical pods are scheduled on available node in the cluster. So container inside the pod share resources such as networking, storage, and volumes. Pod can be moved to different nodes in the cluster to ensure high availability. Pod can scale up or down to meet the demand of the application. So, container inside of pod share such as networking, storage, and volumes. So let's move on to the nodes. So what is node? So a pod always run on the node. A node is worker machine in Kubernetes and maybe either a virtual or physical machine depending on the cluster. Each node is managed by the control plane. A node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the port across the nodes in the cluster. The control planes automatically scheduling take into the account the available resource of each node. So every Kubernetes node run at least Kubernetes process responsible for communication between the Kubernetes control plane and the node, which manage the port and the containers running on a machine. So A container runtime like Docker responsible for pulling the container image from a registry, unpacking the container and running the application. So there are node overview, like you can see that the node is in this shape, and this describe the port and the volume and the app and the node process. So this is all about the ports and the nodes. So let's move on to the Kubernetes replica set. So what is replica set in Kubernetes? So basically replica set is a type of controller in Kubernetes that ensure that a specific number of replicas of a prod specific number of replicas that in a prod are running at a given time. Replica set is a type of deployment that manage multiple pod replicas, which ensure that the desired number of replicas are running at given time. So create you have to create a replica file to define the desired state in the pod within the replica set. Deploy the replica set to the desired Kubernetes cluster. Monitor the replica set to ensure desired number of replicas are run. Update the replica set when it is no longer deleted. So you can ensure a specific number of identical copies of a given pod are running at the same time. So replica controller is responsible for managing the pods, such as creating, deleting and scaling them. So it control watches the pod template, create new pod when needed to reach the desired replica count. So replica count providers scale application quickly and easily by increasing the replica count. So uh, the replica set control all the monitor of the healthy of the pod and will automatically replace your healthy any unhealthy pods. So replica can also be used to ensure a high availability by ensuring that a certain number of replicas are always running. So replica set controller is responsible for managing the replica pods, such as deleting and scaling them. So that's all about the replica set. So let's move on to the namespace. So what is namespace? So namespace in Kubernetes are used to logically separate resources within the cluster, like namespace 1 and namespace 2. In this you have to see that pod 1 and pod 2 that is set by replication set and controller. So it basically optimizing Kubernetes resources. So each namespace can be used as logically group. By using namespace, you can assign a user or team to administer a specific set of resources without affecting other resources in the cluster. So with the help of namespace, you can also be used to isolate resources from each other, such as pod services and config maps. So by using namespace, you can assign a multiple version of an application in different namespace. Namespace also provide a way to limit the impact of malicious or buggy resource on the rest of cluster. If a resource in a namespace become compromise, the rest of cluster still ineffective. So this is all about the namespace. So let's move on to the deployment part. Uh, we don't we don't have to talk about in the deployment part. Still we discuss in the later videos. Just you have to keep a picture in your mind what is deployment, and there are some ports and nodes which are interconnected to each other. So let me show you deploy Kubernetes deployment diagram. So how Kubernetes deployment works. So this is the deployment, and there are some replica set like version 1, version 2, version 3, and there are some ports which are interconnected to nodes. You just have make a picture in your mind. So we're gonna talk about in our incoming videos. So yeah, that's all about the deployment. So this is our video about what is Kubernetes and why we use Kubernetes. Hope you like it. So yeah, thank you.